Hello students and good morning. So now I'm doing class for class 12. The topic is functions. So in the last online class also we were doing some problems on functions. So I think you revise all the problems on functions that we did so far. So if you practice it at home, if you practice all the problems that we did on functions at home, then it will be easier for you to understand the further problems. Okay, so now let's start this question number 8. So in the last online class we did question number 7, and we are doing these problems from the book Senior Secondary School Mathematics for Class 12 by Sri R.S. Agarwal. Right, so let's do from question number 8. So that the function f maps, or it is read as f such that n to n. This n is known as, you know that n is natural numbers. This is the set of natural numbers. This n is the set of natural numbers, and this first n denotes the domain and this second n denotes the codomain. Right? So defined by this function of x is defined as f of x is equal to x plus 1 if x is odd. If x is odd, then you have to use f of x is equal to x plus 1. If x is even, then you have to use f of x is equal to x minus 1. You have to prove that this function is 1, 1 and onto. So 1, 1 means, you know the meaning of 1, 1, isn't it? A function f such that a to b is said to be 1, 1 if distinct element in the set A has distinct element in the set B. That is known as 1, 1 function. And onto function means a function f such that a to b is said to be an onto function if every element in the codomain B has at least one pre-image in the set A. Then this function is known as onto function. And 1, 1 and onto function together, this function is known as bijective function. So how can you prove this function as 1, 1 function mathematically? So in this case, we take f of x1 is equal to f of x2. It should imply that x1 is equal to x2. Then we can say that the function is 1, 1. For onto function, you have to express, let y is equal to f of x, then express x in terms of y. For every element y belongs to the codomain, there exists x belongs to the domain f such that f of x is equal to y. So you have to prove like this. Okay. So now let us prove that this function is 1, 1 and onto. So now we have f of x1 is equal to f of x2. So for all these x1 comma x2 belongs to the domain n. This first n means domain n, right? So now in this case you have to use x1 and x2. Since it is given x is odd and x is even, so first of all you have to take the case number 1. In this case number 1, let us take x1 as even and x2 as odd, right? So this is case number 1, right? So let x1 be odd and x2 be even, right? So let x1 be odd and x2 be even. So therefore f of x1 is equal to f of x2, which implies that since x1 is odd, we have to use this first function. If x is odd, what is the value? For f of x, it is x plus 1. So you have to replace x by x1. So it is x1 plus 1, isn't it? So it is x1 plus 1, which is equal to now what is x2 here? x2 is even here. If x is even, then f of x is equal to x minus 1. So you have to replace x by x2. So it becomes f of x2 is equal to x2 minus x1. So this is x2 minus 1. So if x is even, then f of x is equal to x minus 1. So replace x by x2. So what do we get? f of x2 is equal to x2 minus 1. So here you should write x2 minus 1. Okay. So which implies that x2 minus x1 is equal to 2. I mean, x1 is taken to the right hand side. So it is x2 minus x1, and minus 1 is taken to the left hand side. It becomes 2. So can you say that x2 minus x1 is equal to 2? x2 minus x1 koile 2 huncha ki hudaina? Let us check it. Here x2 is what? x2 is even. Even number means, suppose it is 10. And x1 is odd. Odd means minus 7, which is equal to 3. Yo jaile pani odd number matai aउँछ. That is your, this even number minus odd number will give you only the odd number. It cannot be 2. This x2 minus x1 can never be 2. So this is a contradiction. So from here we cannot prove that x1 is equal to x2 in this case, right? So this is a contradiction. So this is a contradiction, right? So the difference of x2 minus x1 can never be 2. Can never be 2. Okay, so we cannot take this one. We cannot take x1 as odd and x2 as even, because odd number minus even number cannot be 2 always. Okay, you 2 हुँदैन. x2 minus x1 कहिले पनि 2 आउँदैन. It should be odd number always. Even number minus odd number, or odd number minus even number will be always an odd number. That is not your even number. Is that clear? So now let's take case number 2. So now this is your case number 2. So in this case we have assumed x1 as odd and x2 as even. So let us take, let x2 be odd and x1 as even. Let x2 be odd, right? x2 be odd and x1 be even. And x1 be even, right? So now therefore again there is a rule, f of x1 is equal to f of x2, which implies that here x1 is even. If x is even, you have to take f of x is equal to x minus 1. So what is f of x1 now? It is x1 minus 1. It is x1 minus 1 is equal to, now x2 is even here. x2 is even. If x is even, here x1 is odd, sorry. Oh, x1 is even, right. If x1 is even, then f of x1 is equal to, if x is even, f of x is equal to x minus 1. That is x1 minus 1. It's correct. Okay. Now x2 is odd. If x is odd, then f of x is equal to x plus 1. So instead of x, if you write x2, f of x2 is equal to x2 plus 1. So it is x2 plus 1, which implies that x1 minus x2 is equal to 2. So here also even number minus odd number will always give you the odd number. Like you know that x1 is even 100 minus x2 is odd. Odd means you can write 37. So if you subtract it, how much is it? You are not getting even. 2 is even number, right? So you will get 10 minus 7 is 3 and 9 minus 3 is 6. So this is your odd number. You won't get any even number now. So 2 is an even number. So this is a contradiction. So from here you cannot prove that x1 is equal to x2. So this is a contradiction. This is a contradiction. So this is a contradiction. Therefore the difference of x1 minus x2 can never be 2. Can never be 2. Okay. So in this case also we cannot take x2 as odd and x1 as even. Is that clear? So now you have to take x1 and x2 as both odd or x1 and x2 both as even. Okay. So now let us take, let x1 and x2 be both even, right? So therefore f of x1 is equal to f of x2. Therefore f of x1 is equal to f of x2. So what does it imply? Now x and x2 are both even. If x is even, what is the value for f of x? It is x minus 1. So what is the value for f of x1? x1 minus 1, right? So it is x1 minus 1. Similarly, what is f of x2? x2 minus 1. So here minus 1 gets cancels. So x1 is equal to x2. Therefore, in this case, f is 1, 1. Is that understood? If x1 and x2 be both even, then the function f is 1, 1. I think you have understood it. Okay. So this is your case number 3, right? This is your case number 3. Now case number 4. Let us take x1 and x2 be both odd. Let x1 and x2 be both odd now. Let x1 and x2 be both odd, right? So therefore f of x1 is equal to f of x2, which implies that now here x1 and x2 be both odd. Duitai odd cha yaha. So if x is odd, what is the value for f of x? It is x plus 1. So you have to replace x by x1. So f of x1 is equal to x1 plus 1. It is x1 plus 1 is equal to, what is f of x2? x2. Here also x2 is odd. If x is odd, then f of x is equal to x plus 1. So it is x2 plus 1. So it is x2 plus 1. From both the sides, you can cancel this plus 1. So what do we get? So in the next step, it implies that x1 is equal to x2, which implies that x1 is equal to x2. So now, therefore, the function f is 1, 1. Therefore, the function f is 1, 1. So therefore, the function f is, oh sorry, not odd. The function f of is the function f is 1, 1. Okay. So we have proved that the function f is 1, 1. Is that clear? So now we have to prove onto function. For onto function, you have to take y belonging to the set N, that is your codomain. For every y belong to the codomain N, it should have pre-image in the domain N. Okay. So let y belongs to the set N, that is your codomain. Let y belongs to the set N, that is your codomain. Now in this case, let us assume let y be odd. So in this case, there is odd and even term. So let us assume that y be odd. Let us assume that y be odd. Therefore y minus, so let us assume y be even, right? Let y be even. Let y be even. Let y be even. So therefore, what is y minus 1? Y minus 1 is odd. Therefore, y minus 1 is odd, right? So let us assume let y be even first. Okay? Let y be even. If y be even, so what can we say about y minus 1? Y minus 1 is odd. So you can use this one. So therefore, f of x is equal to f of y minus 1. Right? So therefore f of x is equal to f of y minus 1. So here y minus 1 is odd. That means we have to use this function. F of y minus 1 is equal to f of x is equal to x plus 1. So if you put instead of x y minus 1, it should be y minus 1 plus 1, isn't it? So it is y minus 1 plus y minus 1 plus 1, right? So here plus 1 minus 1 gets cancels, which is equal to y. So I think you have understood it. Okay, so let us take, let y be odd. Let y be odd, right? So therefore you know that y plus 1 will be even. Odd number ma 1 add गर्ने बित्तिकै के हुन्छ, even भइहाल्छ. ठीक छ? So in this case also you have to prove that f of x is equal to y, so that it is onto function, right? So therefore let us put here f of x is equal to, so here instead of x what should you put? Y plus 1, f of y plus 1, which is equal to, now since y plus 1 is even, you have to use this function x minus 1. Instead of x you put y plus 1. So y plus 1 minus 1. 1 gets cancels, which is equal to y. Is that clear? So you can write here. Now from here we can write down that for every y, so for each y belonging to the set N, that is your codomain has pre-image in the domain N. Therefore the function f is onto. Hence the given function f is 1 1 and onto. Hence the given function f is 1 1 and onto. So I think you have understood it. So you can copy it. We'll do the next question now. So now we'll do the next question, that is question number 9. So that the function f such that n to n, here n is also a natural number. N is the set of natural number. First n denotes the domain and the second n denotes the codomain, defined by f of x is equal to x plus 1 whole divided by 2 if x is odd. So if x is odd, you have to use f of x is equal to x plus 1 divided by 2. And f of x is equal to x by 2 if x is even. Suppose x even, you have to use function of x is equal to x by 2. You have to prove that this function is a many one and onto function. Many one onto function. You have to prove that this function is many one onto function. Many one means 2 or more than elements in the domain have the same image in the codomain. That is your many one. Okay. So now in this case, natural numbers means it starts from positive 1, positive 2, positive 3 up to plus infinity, right? Suppose if you put x is equal to 1 here, you know that 1 is odd number, isn't it? We are proving that it is many 1. So if you put x as odd, we are putting x is equal to 1, isn't it? That is f of 1. So since x is odd here, we have to use this function x plus 1 by 2 if x is odd. So it is 1 plus 1 divided by 2, which is equal to 1. Okay. If x is even means you can put 2. Therefore f of 2 is equal to, if you put x is equal to 2, here 2 is even, isn't it? We can use this function f of x is equal to x by 2 if x is even. So we can use this function, that is it will be 2 by 2, which is equal to 1. Okay. So we are getting the same values for f of 1 as well as f of 2. So which implies that f of 1 is equal to f of 2. That means we are getting f of x1 is equal to f of x2, but 1 is not equal to 2. That means it is not 1 function. That means the function f is many one function. So therefore the function f is many one function. Therefore the function f is many one function. Okay. So now you have to prove that this function is onto function. You know how to prove f as onto function. So you have to take any arbitrary element y belongs to the codomain. Then there exists x belongs to the domain such that f of x is equal to y. Okay. So now let us assume let small y belongs to the codomain n. N means here n is the set of natural numbers. Let y belongs to n codomain. N codomain, right? So let y be odd. Let y be odd. That means we can assume therefore 2y minus 1 is also odd. So therefore 2y minus 1 is also odd, right? 2y minus 1 is also odd. Since y is odd, 2y minus 1 is also odd. So if you put 1, 2 ones are 2, minus 1 is 1. If you put y is equal to 3, 3 2s are 6, minus 1 is 5, and so on, right? So now therefore let us write f of x. Now we have to prove f of x is equal to y. So f of, instead of x you put 2y minus 1. So 2y minus 1 is odd. You know that, isn't it? So 2y minus 1 is odd. If x is odd, you have to use this function f of x is equal to x plus 1 by 2. So it becomes, instead of x there is 2y minus 1. So you x was 2y minus 1 also. That is 2y minus 1, then plus 1 is there. 2y minus 1 is the value for x. So we have written 2y minus 1 here. Plus 1 is there. Plus 1 divided by 2. Here 1 gets cancels. So which is equal to 2y by 2, which is equal to y. So we have proved that f of x is equal to y. Is that clear? Now again let y be even. Let y be even. Therefore 2y is also even. Therefore 2y is also even. Okay. So if x is even, you have to use f of x is equal to x by 2. So therefore f of x is equal to, instead of x you put 2y is equal to, if x is even you have to use this function f of x is equal to x by 2. So instead of x you put 2y. 2y by 2 is equal to 2 gets cancels, which is equal to y. So here also we have proved that for this condition y be even, we have proved that f of x is equal to y. Okay. So now what can you write here? For each, therefore for each y belongs to the n codomain has its pre-image in the domain n. In the domain n. So therefore the function f is onto function. Therefore the function f is onto function. So hence the function f is many one onto function. Many one onto function, that is proved. So I think you have understood it. You can copy it. So now we'll do the next question. So now we'll do the next question, that is question number 10. so that the signum function चाहिँ कसैलाई भन्छ भन्दाखेरि यस्तो टाइपको फंक्शन, that is f of x is equal to constant 1 if x is greater than 0. Whatever may be the positive values of x, f of x is always 1. Whatever may be the value for x less than 0, x is negative here. Whatever may be the negative values of x, f of x is equal to minus 1. And if x is equal to 0, then f of x is also 0. So this type of function is known as what? Signum function. You have to remember this one, okay? So you say yaad garnu timale, the signum function is f of x is equal to 1 if x greater than 0, f of x is equal to 0 if x exactly equal to 0, f of x is equal to minus 1 if x is less than 0. So you have to prove that this signum function f such that real to real number means every defined numbers is known as real number. This first R is known as the domain, second R is known as the codomain. It is defined by this signum function. You have to prove that it is neither 1 1 nor onto. So you 1 1 function पनि हैन onto function पनि हैन भने प्रुभ गर्नुलाई चाहिँ हामी एक्जाम्पल दियो भने काफी भइहाल्छ. Example दियो भने you can prove it. Okay, so it is neither 1 1 nor onto. यो 1 1 function पनि हैन 1 2 function पनि होइन भनेर हामीले प्रुभ गरेर देखाउनु पर्छ. ठीक छ? So now solution. So now in this case x is greater than 0. That means if f of 2 is there, if we put x is equal to 2, that means it is x is greater than 0. That means what is the value for f of 2? Which is equal to 1. Right? So again you can put f of 3. So f of 3 is equal to, what is f of 3 here? 3 is also greater than 0. That is your positive. What is the value for f of x? That is your 1. So in this case we see that f of 2 is equal to f of 3. But 2 is not equal to 3. That means this is not 1 1 function. So therefore the function f is not 1 1. Therefore the function f is not 1 1. Is that clear? So now whatever may be the positive values of x, okay, it may be plus 1 plus 2, any real number, any real positive number, f of x is always 1. If you put x is equal to 0, f of x is equal to 0. If x is less than 0 means any negative real numbers, f of x will be minus 1. That is, what is the range of the function f? That is 1 comma 0 comma minus 1 only. So here range of the function f is equal to, it is the set of only these three numbers, that is 1 comma 0 comma minus 1. Is that clear now? So यो चाहिँ के भयो तिमीको, यो भयो codomain. That is, this belongs to the second R, that is your codomain. तर यो रियल नम्बरमा त अरु नम्बरहरु पनि छ. यो रियल नम्बरमा तिमीको +2 +3 +4 एनी रियल नम्बर, तर त्यो रियल नम्बर चाहिँ यहाँ छैन except 1 0 and -1. So you know that this 2, we see that, let us write, we see that 2 belongs to R, that is your codomain, that is your codomain, right? तर यो जुन चाहिँ 2 codomain यो रियल मा पर्दैछ, रियल नम्बरमा पर्दैछ, यसको कुनै पनि प्री इमेज यो रियल नम्बरमा छैन. Is that clear? So we see that 2 belongs to real number codomain, has no pre-image, has no pre-image in the domain R, in the domain R, in the domain R. I think I want to study it. Not only 3, 4, 5, 6, etc. 2, 3, 4, 5, 6, 7, etc. They do not have any pre-image in the domain R. Not only 2. Also, -2, -3, -4, -5, -6, etc. don't have any pre-image in the domain R. That means it is into function, isn't it? So that means it is not onto function. Is that clear to all of you? So now we can write here, that is codomain. यो codomain R मा चाहिँ पुरै रियल नम्बर पर्छ. So this range of the function f is a subset of the codomain R, isn't it? So it is an into function but not onto function. Is that clear to all of you? Here I have an example. We see that 2 belongs to the real number codomain, has no pre-image in the domain R. Esko pre-image ai domain R ma chaina. That means it is not onto function. So here you can write here also, range of f is a subset of codomain R. Okay, range of f is a subset of codomain R. So here range of f is 1, 0, -1. तर यो codomain real number मा त पुरै real number हरु पर्छ नि त, including -1, 0, -1. That means every element of the set of range of f is also an element of the set of codomain R. That means range of f is a subset of codomain R. So I think you have understood it. This is a subset. That is range of f, this 1, 0, -1 is the subset of all those real numbers which belongs to the codomain. So hence, so here we can, therefore the function f is not onto. Therefore the function f is not onto. So hence the given function, hence the signum function signum function is neither, hence the signum function is neither hence the signum function is neither 1 nor onto function. So we have proved it. So I think you have understood it. So you can copy it. We'll do the next question now. So now we'll do the next question, that is question number 11. Let capital A is equal to R means real number minus 3. भनेको चाहिँ यो रियल नम्बरमा सबै नम्बर आउँछ, all defined numbers except 3. 3 चाहिँ यहाँ इन्क्लुड हुनु हुँदैन. 3 चाहिँ आएन यो रियल नम्बरमा. ओके, एन्ड B is equal to रियल नम्बर minus 1 भनेको चाहिँ यहाँ जति पनि रियलको डिफाइन्ड नम्बर छ सबै छ एक्सक्लुडिङ 1. 1 चाहिँ यहाँ छैन भनेको. बुझ्यो? 1 चाहिँ परेन. Let f such that a to b. Let f such that a to b defined by f of x is equal to x minus 2 divided by x minus 3 for all x belongs to the set A. अब हेर यहाँ के दिएको थियो, रियल नम्बर minus 3 भनेको यो रियल नम्बरमा 3 चाहिँ हुँदैन, किनभने 3 भयो भने यो 3 minus 3 के भयो? 0. That is your undefined. यो 3 ले गर्दा undefined हुन्छ, त्यही कारण यहाँ -3 लेखेको. Is that clear to all of you? So this function f of x is defined if x not equal to 3. किनभने x is equal to 3 भयो भने चाहिँ के हुन्छ, यो undefined हुन्छ. तर x को अरु रियल भ्यालुज अफ x मा चाहिँ यो सबैमा के छ, डिफाइन्ड एक्सेप्ट x is equal to 3. So now, so that f is 1, 1 and onto. So here A is the domain and B is the codomain. So here also it is given that in codomain B real number minus 1. यो codomain B मा चाहिँ real numberहरु छ except 1. अब अहिले म बुझाउँछु यो चाहिँ किन 1 दिएको. You will understand it. So let us do this problem. You have to prove that, you have to show that f is 1, 1 and onto. यो function 1, 1 पनि छ, onto पनि छ भनेर prove गर्नु. So this question is very very important. So this type of question you might get it in your HS examination. Okay. Now first of all you prove that the function f is 1, 1. So in order to prove it mathematically you have to prove that we have f of x1 is equal to f of x2. It should imply x1 is equal to x2, right? So here it is given that f such that a to b defined by what? Defined by f of x is equal to x minus 2 divided by x minus 3. So let us take x as x1 and x2. Let x1 comma x2 belongs to the set A. Belong to the set A, that is your domain. Belong to the set A, that is your domain. Okay, so in this A there is no 3 here. All the real numbers are there but except 3. So therefore f of x1 is equal to f of x2. So it implies that since f of x is equal to x minus 2 by x minus 3, so if you put x1 instead of x, so it becomes x1 minus 2 divided by x1 minus 3 is equal to, what is f of x2 now? Instead of x you have to write x2 now. This is x2 minus 2 divided by x2 minus 3. I think you have understood it. So now let us simplify it. You can do cross multiplication, which implies that now you do cross multiply x1 x2 minus 3x1, right, minus 2x2 minus 2 minus plus 3 2s are 6, which is equal to, now cross multiply here, x1 x2 minus 2x1 minus 3x2 plus 6. Okay, from both the sides you can cancel this x1 x2 and this plus 6 gets cancels. So what are the remaining terms now? So let us write down the remaining terms now here. Minus 3x1 minus 2x2, which is equal to minus 2x1 minus 3x2. Minus 3x2. Now you can keep the terms containing x1 on the left side and x2 on the right side. Okay. So minus 3x1, you take minus 2x1 to the left hand side, becomes plus 2x1, which is equal to minus 3x2. Take minus 2x2 to the right hand side, becomes plus 2x2, right? Which implies that this is minus x1 is equal to minus x2. Here also minus minus gets cancels. So it is x1 is equal to x2. So this f of x1 is equal to f of x2 implies that x1 is equal to x2. So therefore the function f is 1 1. Therefore the function f is 1 1. So we have proved that the function f is 1 1. So I think you have understood it. Now we will prove that f is onto function. So how will you prove that f is onto function? So now in this case we take y belonging to the set B, has its pre-image x in the set A, such that f of x is equal to y. Okay. Now let y belongs to the set B. Let y belongs to the set B. So therefore there exists x belongs to A such that f of x is equal to y. You have to prove it, right? Such that you have to prove this, f of x is equal to y. So now what will you do here is, let us assume y is equal to x minus 2 by x minus 3. So let us assume y is equal to x minus 2 divided by x minus 3. तो इसको मेथड के हुन्छ, पहिला यो जुन चाहिँ फंक्शन अफ x minus 2 by x minus 3 भनेर दिएको छ, यसलाई हामी पहिला के सपोज y. Now you have to express x in terms of y, right? So you can do cross multiplication here. So xy minus 3y is equal to, so below y there is 1, cross multiplied by 1, so it is x minus 2. Or you can keep the terms containing x on the left hand side. So it is xy minus x is equal to minus 3y, take it to the right hand side. So it is 3y minus 2. So here x is common. So y minus 1 is equal to, this is your 3y minus 2, or x is equal to 3y minus 2 divided by y minus 1. Okay. Now this y belongs to the set B. In the set B it is given that real number minus 1. Here real number, sabai real number includes except 1. Kina bhanda यो बाट आएको. यदि y is equal to 1 भन्दै 1 minus 1 0 undefined भन्दै. That's why it is written as real number minus 1. What is meant by real number minus 1? Sabai real number छ त्यहाँ B मा, set B मा all real numbers are included here except 1. 1 मात्रै छैन त्यहाँ. किन 1 छ भने चाहिँ के हुन्छ यो x is undefined भइहाल्छ. So that's why it is given as r minus 1. Is that clear? So now we have to prove that f of x is equal to y. So now f of x is equal to, instead of x, what will you put? F of 3y minus 2 divided by y minus 1. Right? So next, what will you do? Which implies that, which is equal to, or you can write is equal to, now instead of x there is 3y minus 2 upon y minus 1. What is f of x here? F of x is equal to x minus 2 divided by x minus 3. So x को जग्गामा अब हामी के हाल्छौं 3y minus 2 by y minus 1. So this becomes 3y minus 2 divided by y minus 1. This is the value for x. Right? Minus 2 divided by, in the denominator, instead of x you put 3y minus 2 divided by y minus 1, then minus 1 is here, then minus 1 is there. Okay, so now let's simplify it. Let us simplify it now. So it is 3y minus 2. Oh sorry, this one is x minus 2. X is 3y minus 2 upon y minus 1. So here x is 3y minus 2 divided by y minus 1. Minus 3 is there. It should be 3, not 1. This one, we are putting the value of x is equal to 3y minus 2 upon y minus 1 in the given function of x. That is x minus 2. X is 3y minus 2 upon y minus 1 minus 2 divided by what is x? 3y minus 2 upon y minus 1 minus 3 is there. Now let us simplify it. So what's the LCM in the numerator? This is y minus 1. So mathi ke huncha 3y minus 2 minus 2y minus minus plus 2. Here also y minus 1 is the LCM. Below 3 there is 1. So 1 and 1 minus 1, what is the LCM? Y minus 1, right? So this is 3y minus 2 minus 3y plus 3. So here y minus 1 gets cancels. Here 2 gets cancels. Here 3y gets cancels, which is equal to, what is 3y minus 2y? That is your y divided by what is 3 minus 2? That is 1, which is equal to y. Is that clear? So we have proved that f of x is equal to y. So therefore, what can you write? So therefore, for each y belongs to the set B, there exists or for each y belongs to B, for each y belongs to B has a pre-image, for each y belongs to B has a pre-image in the set A, right? So therefore the function f is onto. Therefore the function f is onto. So what can you write? Hence the given function f is 1 1 and onto. So it is proved. So hence it is also a bijective function. So I think you have understood it. So you can copy it. We'll do the next question now. So now we are doing the exercise 2A, page number RF30 from the book. This book is Senior Secondary School Mathematics for Class 12 by Sri R.S. Agarwal. So this is exercise 2A, page number RF30. So we are doing question number 5 now. So you have to show that the function f such that R to R means real numbers. Okay. Z is known as the set of integers. Q is known as the set of rational numbers. You should know it. Okay. R means set of real numbers, all defined numbers. Right. N means set of natural numbers. Set of natural numbers. What is Z? Set of integers. Set of integers. Set of integers. What is Q? Q is set of rational numbers. Q is set of rational numbers. And so on. Right? R dekho cha bhane set of real numbers bhayo. All defined numbers. N bhaneko set of natural numbers. You know natural numbers. Z means set of integers. Q means set of rational numbers. Is that clear to all of you? Okay. So you can copy it. So now you have to show that the function f such that this first R is known as the domain. I already told you that. And this second R is known as the codomain. It is defined as f of x is equal to 1 plus x square is many 1 into. You have to prove that the function is many 1 and into function. Okay. So now let us prove it. Here given function is f such that real to real number defined by f of x is equal to 1 plus x square. Now first of all you prove that the function is many 1 function. Okay. If you put x is equal to 1 is a real number, isn't it? X is equal to 1, x is equal to minus 1 is a real number, you know that, right? So f of 1 is equal to 1 plus 1 whole square is equal to 1 plus 1 is equal to what? 2. But if you put f of minus 1, what do we get? 1 plus minus 1 whole square is equal to 1 plus 1 is equal to 2. That is both the real numbers 1 and minus 1, which belongs to the domain R, have the same image 2, which belongs to the codomain R. So यो दुईटै pre-image को same image छ त यहाँ 2 2 भनेपछि यो many 1 function भएको. हामीले यसलाई यसरी लेख्दा पनि हुन्छ, which implies that 2 2 भयो. That means f of 1 is equal to f of minus 1, but 1 is not equal to minus 1. Therefore, that means the function f is many 1. Therefore, the function f is many 1. The function f is many 1. Is that clear? त अब यहाँ के हुन्छ भन्दा फेरि हामीले एउटा एक्जाम्पल दियौं. अब एक्जाम्पल दियौं कि यो इन्टु फंक्सन हो भनेर. Into function भनेको चाहिँ के हो भन्दा फेरि there is at least one element in the codomain R which doesn't have any pre-image in the domain R. Is that clear? There is at least one element in the codomain R which does not have pre-image in the domain R. That is your into function, right? So त तिमीले यो जुन चाहिँ x को भ्यालु छ, x मा तिमीले जति सुकै भ्यालु हाल, हैन? Whether it is positive real number or negative real number, f of x will be always positive, right? F of x will be always positive. तर यो जुन चाहिँ codomain real number छ, त्यसमा त negative numberहरु पनि त आउँछ नि त. That means we see that minus 1, not only minus 1, it may be minus 2, minus 3, minus 4 and so on. We see that minus 1 belongs to the real number, that is your codomain. Second R भनेको हाम्रो के हो? Codomain, that is your codomain, does not have any pre-image, does not have any pre-image in the domain R. In the domain R. बुझ्दैछ? यो जुन चाहिँ -1 छ, -1 त यो सेकेन्ड R, that is कोडोमेन R मा नि त पर्यो नि त -1 रियल नम्बर. तर यसको कुनै प्रकारको इमेज यो डोमेन R मा हुँदैन. भनेपछि यो इन्टु फंक्सन भइगयो. So hence the function f is what? Hence the function f is into function. Hence the function f is into function. So therefore the function f is many one into function. Many one into function. That is proved. Okay, so you can copy it. Now we'll do the next question now. So now we'll do the next question, that is question number 6. It is same as question number 5, right? So let us revise it. So question number 6 is so that the function f such that, again, real to real number. First R is known as what? Domain. Second R is known as codomain. It is defined as f of x is equal to x to the power 4, right? Is many one and into. Yo many one function and into function. That means it should not be 1 and it should not be onto function. So just give an example to prove it. Okay, so now here given is, so you can use the same method as we have done in problem number 5. So here given is f such that real to real number defined by f of x is equal to x to the power 4, right? So let us put here 2. So if you put f of 2, so it is 2 to the power 4, which is equal to 16, isn't it? 2 to the 4, 4 to the 8, 8 to the 16. 2 is multiplied 4 times, which is equal to 16. If we put f of -2, what do we get? -2 whole to the power 4 is equal to, what is -2 whole to the power 4? Again, minus is multiplied 4 times, that is your plus, and 2 to the power 4 is always 16. That means, which implies that f of 2 is equal to f of -2, but you know that 2 not equal to -2. That means this is not 1, so the function f is many one function. Therefore, the function f is many one. So we have proved that the function f is many one. Okay. Now, अब यहाँ हामीले जुन चाहिँ यो x डोमेनमा पर्दैछ, डोमेन R मा, त्यो x मा हामीले जति नै नेगेटिभ साइन हालौं न, x टु द पावर 4 ले गर्दा के हुन्छ, त्यो जहिले पनि पोजिटिभ मात्रै हुन्छ. त यो जुन चाहिँ कोडोमेन R छ, यसमा त नेगेटिभ नम्बर्सहरु पनि त छ, तर त्यो कुनै पनि नेगेटिभ नम्बर्सको प्री इमेज चाहिँ यो डोमेन R मा हुँदैन. I think you have understood it. यसमा बुझ्नुपर्छ है तिमीले. You try to understand it, right? यहाँ जति पनि कोडोमेन रियल नम्बरमा नेगेटिभ नम्बर्सहरु छन्, त्यो नेगेटिभ नम्बर्सहरुको कुनै पनि प्री इमेज चाहिँ यो डोमेन R मा छैन. That means it is into function. This is not onto function. This is into function, right? So here we see that, let us give an example. We see that -2 belongs to the codomain R. Codomain R भनेको second R, right? Codomain. This is your codomain. Doesn't have pre-image, does not have pre-image in the domain R. In the domain R. We see that -2 belongs to the real number, that is your codomain. We see that -2 belongs to the real number codomain, does not have pre-image in the domain R. Is that clear? So therefore the function f is into function. Therefore the function f is into function. Hence we have proved that the function f is many one. Hence the function is many one and into function. Hence the function f is many one and into function. So proved. Is that clear now? So I think you have understood it. So you can copy it. This was same as problem number 5. Okay. So now we'll do the next problem. So now we'll do the next question, that is question number 7. So question number 7 is, so that the function f such that real to real number. Here also it is given that R means a set of real numbers defined by f of x is equal to x to the power 5 is 1, 1 and onto. You know how to prove this function as 1, 1 and onto function. Okay. So we did previous questions. That in that question also we proved that the function is 1, 1 and onto function. Okay, so we can use the same method here also. Okay, so now given, so what is given here? F such that real to real number defined by what? F of x is equal to x to the power 5. Right. Now let us assume, so how will you prove that this is an 1, 1 function? F of x1 is equal to f of x2. We have f of x1 is equal to f of x2. It should imply that x1 is equal to x2, right? So let x1 comma x2 belongs to the real number domain. This first star, that is your domain, right? That is your domain. So we have f of x1 is equal to f of x2, which implies that what is the value for f of x1 now? Instead of x you put x1, this is x1 to the power 5. x1 to the power 5 is equal to what is f of x2? That is your x2 to the power 5. So if the powers are equal, bases must be equal. That is x1 is equal to x2. So we have proved that this is your x1 is equal to x2. Is that clear? So which proves that therefore the function f is 1, 1. Therefore the function f is 1, 1. Is that clear? So what is the method for proving that the function is onto function? So let us assume this f of x is equal to x to the power 5 as y. Then you have to express x in terms of y, right? So let y is equal to x to the power 5. So what is the value for x now? X is equal to, now it is just like cross multiplication in the power. So if y is equal to x to the power 5, then x is equal to y to the power, it will be 1 upon 5. It is just like cross multiplication in the power. That is x is equal to y to the power 1 by 5. Okay. Now for every y belongs to the real number, if y is a real number, so real number whole to the power 1 by 5 is also a real number, then there exists x belongs to the real number such that you have to prove f of x is equal to y. Okay, such that f of x is equal to, what is the value for x here? This is f of y to the power 1 by 5. Now here instead of x you have to write y to the power 1 by 5. Okay, so this becomes y to the power 5 is the value for x, whole to the power 5 is also there, right? X to the power 5 is there. Instead of x you put y to the power 1 by 5. So y to the power 1 by 5 is there, whole to the power, this power 5 is also there. Okay, so here 5 gets cancels, which is equal to y. So that is f of x is equal to y. Okay, so hence you have to write here so यहाँ मैले के भन्दै थिएँ भन्दाखेरि we have proved that f of x is equal to y. For every y belongs to the real number, that is your codomain, there exists x belongs to the domain R such that you have to prove f of x is equal to y. So we have proved it. So अब हामी के लेख्छौं? We have to write for each y belongs to the real number R, that is your codomain, there exists for each y belongs to R, that is your codomain, there exists pre-image in the domain R. That is, for each y belonging to the set of real numbers codomain, there exists pre-image in the domain R. Okay, so what can you conclude from this one? The function f is onto. Therefore the function f is onto. Hence the function f is 1 1 and onto. So I think you have understood it. So we have proved it. Okay, so you can copy it. Now we'll do the next question now. So now we'll do the next question, that is question number 9. So that the function number 1 f such that n to n means set of natural numbers. This first n is the set of natural number, that is known as domain, and this second n is known as the set of natural numbers, that is known as codomain. And it is defined as f of x is equal to x square is 1 1 into. You have to prove that this is 1 1 into. Okay, so now let us do this problem. Now first you prove 1 1 function. So here given is f such that n to n defined by f of x is equal to x square. So you have to prove 1 1 function. Okay, so let us take two elements x1 and x2 belonging to the set n, that is your domain. These are natural numbers, right? Natural numbers means it should be positive integers, +1 +2 +3 etc. Okay, so therefore we have f of x1 is equal to f of x2, which implies that, what is f of x1? Instead of x you put x1, so it will be x1 square is equal to x2 square. Actually it is x1 is equal to plus minus x2, but you cannot take a negative sign here because it is the set of natural numbers. It should be always positive. So you have to take only x1 is equal to x2. Therefore the function f is 1 1. Therefore the function f is 1 1. Is that clear to all of you? So I think you have understood it. Okay, Now we have to prove that this is an into function. The into function को लागि हामी एउटा example दिउँ. एउटा example ले तिमीले prove गर्न सकिहाल्छौ into function. Okay? So now for into function, right? So for into function, so how will you prove that this is an into function? So you know that whatever may be the values of x here, whether it is, so whatever may be the value for x here, that is, if you put x is equal to 1, it will be 1. If you put x is equal to 2, it will be 4. If you put x is equal to 3, it will be 9. If you put x is equal to 4, it will be 16. Okay? So you know that in this natural number, 3 belongs to this natural number. Isn't it? 3 belongs to this natural number. Is that clear? 3 belongs to this natural number, that is codomain. तर यो 3 natural number को कुनै pre-image चाहिँ यो natural number domain मा हुँदैन. Is that clear to all of you? I think you have understood it. Is that understood? Or you may take it as let y is equal to, suppose it is x square. Let y is equal to x square, right? So what is the value for x? It is only root over y. You can take only positive sign here because it should not be negative, because it is the set of natural numbers. Because x is a set of natural numbers, you cannot write negative sign here. Is that clear? So if you put, if y is equal to 2, then x is equal to root 2. So this root 2 does not belong to the set n, that is your domain. It does not belong to the set n, natural number. That is your domain, isn't it? So your domain ma natural number by root 2 नै पर्दैन. So you जुन चाहिँ, if you put y is equal to 2 in this case, so x is equal to root over 2. Is it natural number? No, the root over 2 is not a natural number. It is irrational. It is irrational number. You know that, isn't it? So it does not belong to the set n. Therefore 2 belongs to y, doesn't have any pre-image in the domain. So 2 belongs to y, does not have any pre-image in the domain n. So I think you have understood it. Therefore the function f is into. Therefore the function f is into. Hence the function f is 1 into function. 1 into. So it is proved. Hence the function f is 1 into. Is that clear? So now we'll do the next question, that is 9 number 2. We'll do 9 number 2 now. So now we'll do the next question, that is 9 number 2. You have to prove that the function f such that z to z means set of integers. It may be positive integers, it may be negative integers, including 0 also. Okay, z is a set of integers. It may be positive integers, it may be negative integers, including 0. Okay, so you have to show that f such that z to z, that is the set of integers, defined as f of x is equal to x square, is many 1 into function. You have to prove it. Okay, so for many 1 you have to give the example दियो भने भइहाल्छ. ठीक छ? So given is f such that z to z defined by, so it is defined by f of x is equal to x square, right? Now this x belongs to the set of integers z, that is your domain. Okay, so you can put x is equal to 1 here. So f of 1 is equal to 1 whole square is equal to 1. and you put f of minus 1, which is equal to minus 1 whole square is also 1. So here we see that, so which implies that we see that f of 1 is equal to f of minus 1, but is 1 equal to minus 1? But 1 is not equal to minus 1. 1 is not equal to minus 1. Therefore, so this implies that the function f is many 1. So how is it many 1? This both 1 and minus 1 belongs to the set of integers, that is Z domain. They have the same image 1 here. They have the same image 1 in the codomain Z. That means many 1. Okay? यो दुईटा 1 र minus 1 चाहिँ केमा पर्यो? डोमेन Z मा पर्दैछ. यो दुईटैकै 1 र minus 1 को इमेज चाहिँ सेम छ 1. That is in codomain Z. So that's why it is many 1. So therefore the function f is many 1. Okay? Now you have to prove that this is an into function. You have to prove that this is an into function. So let us assume let y is equal to x square. Let y is equal to x square. So what is the value for x here? It is root over y. It is root over y. You may have plus minus also. You can write plus minus, minus लेख्नु plus लेख्नु भयो. ठीक छ? So if you put y is equal to 2. So if y is equal to 2, then x is equal to root over 2. Is root over 2 an integer? Root over 2 is not an integer, right? So which does not belong to this Z. That is your domain. So root over 2 is not an integer. That is, it does not belong to the set Z. That is your domain. Is that clear to all of you? So therefore 2 belongs to that is this 2 belongs to this Z codomain. 2 belongs to the Z codomain, right? This 2 belongs to this set of integers, that is Z codomain, does not have pre-image, does not have pre-image in the domain Z, in the domain this Z. Is that clear? So therefore the function f is, therefore the function f is into, therefore the function f is into function. किनभने यो 2 जुन चाहिँ छ number, that 2 belongs to the set of integers, that is your codomain. So this is x equal to root 2, but root 2 is not your integers. That is यो 2 को चाहिँ it does not have any pre-image in the domain Z. So that's why the function f is into function. So hence the function f, hence the function f is many 1 into, is many 1 into. So it is proved. So I think you have understood it. You can copy it. So this much is for today. त आज पनि हामीले जति पनि प्रब्लम्सहरु गर्यौं सबै घरमा राम्रोसँग हेर्नु बुझ्नु फेरि त्यसलाई घरमा प्र्याक्टिस गर्नु बुझ्यो यसलाई एनालाइज गर्ने कोसिस गर्नु है तिमीले यसलाई जति तिमीले एनालाइज गरेर बुझ्ने चेष्टा गर्छौ त्यति नै तिमीलाई यो फंक्शन्स क्लियर हुँदै जान्छ ठीक छ सो इन द नेक्स्ट क्लास वी विल डू मोर प्रब्लम्स on this type of functions okay so this much is for today